Thank you for joining us for our presentation of the plight of the honeybee. I'm Karin Kolb, and my co-presenter is DeMarcus Green. We have one more member of our project team, Rachel Bishop. We are all graduate students at Kennesaw State University in the Masters of Science in Applied Statistics program. All of us are guilty of swatting away a bee if it comes near us, but we must be mindful of the importance of bees. They are actively pollinating the majority of our food crops. In the United States alone, 14 billion in crop value can be attributed to the honeybee pollination. And of course, we rely on honeybees for their production of honey.
Even though honey may be a big export of the honeybee, it's also responsible for a lot of crops. It's also responsible for various crops as well, such as watermelon, different vegetables, different crops nationwide. So if these go extinct, then we're going to see a decrease in these crops as well. So that will have an impact on the economic value, food, everything. So a honeybee is very vital to this nation's backbone. So we want to see if the pesticides that farmers use are having a big effect on the honeybee, because they're using these pesticides for different reasons, but it's having a negative impact on the honeybees as an underlying reason. So we want to see how these pesticides are affecting the honeybee population.
The production of honey is the evidence of healthy, active bees. Since it is a measurable entity, it can be analyzed, and then conclusions can be drawn about the viability of honeybees. The United States started widespread use of neonic pesticides on crops in 1995. So there's data available now to analyze the effects of the use of some of these pesticides. This analysis could reveal if these pesticides are contributing to the decrease in honey production.
So for our research question, we wanted to see that the specific use of neonic pesticides have negative consequences for honeybee production and their total yield as well. We chose to look at 5 specific neonic pesticides, and my co-presenter will tell you about those in a little bit.
Neonicotinoid pesticides are insecticides that are derived from nicotine. They're the most widely used class of insecticide. As of 2015, they were being used in 120 countries. These pesticides work by attacking the central nervous system of an insect, which eventually causes paralysis and leads to death. 3 of the neonics that are included in this study can be seen in this diagram: imidacloprid, thiamethoxam, chlorothianidin, and 2 additional ones are also included in our study: acetamiprid and thiacloprid. As we continue the presentation, we will refer to these neonics by the 2-letter abbreviations IM, TH, CL, AC, and TI, respectively.
And these pesticides have already been seen to have some type of impact on the honeybee colony count and the honeybee yield. We saw in a previous study that a little over 31% of the honeybees exposed to pesticides, they failed to return to their hives. So meaning that they died when they came in contact with these pesticides, meaning that the colony count was affected, and in turn, the honeybee yield and the honey yield will be affected as well. And if they are coming in contact with these pesticides, and they are actually able to return back to the hive, that's going to have a more long-term effect on the colony count, because they're going to affect a more widespread area. And the honeybees already in the colony will be affected. I mean, the honeybees that go to different colonies will be affected as well. So the colony count, the colonies are being affected, the honeybee yield will be affected, and the honey yield will be affected as well. So them coming in contact with these pesticides has a very long-term effect.
The data set used for our analysis is provided by the National Agricultural Statistics Service. The U.S. Department of Agriculture uses this service as their primary reporting source. This data set also includes results from the U.S. Geological Survey. In all, we have 20 years of data about honey production, colony count, and pesticide usage for most of the United States.
For our first graph, we chose to use a heat map that shows the pesticide usage across the country. If you see by our legend, as it goes from burnt orange to blue, is the heavier that it gets. So you see mainly in the South and the East and somewhat in the West, Midwest, it's all about the same. They use about the same amount of pesticides. So the pesticide usage is pretty common in those areas. But when you get to Texas, California, the bigger states, and then you get around the Great Lakes regions, you see that it gets to the blue where it's the heaviest. So you see that California, Texas, Illinois, they are the biggest users of pesticide usage because of the size of the state, and it may have something to do with their crop production as well. And then based off of that pesticide usage, we chose to show the heat map of where the yield and the colony count decreased based on that usage. And you see that the darker regions that we saw in the previous heat map with California, Texas, those regions, and the Great Lakes, they have more years that the yield actually decreased. So you see that the pesticide usage and the yield are showing hand in hand.
The USDA provides a website full of information pertaining to the agriculture industry. There is a section dedicated to their pesticide data program. The addition of an interactive tool, such as a decision tree, could be a resource for concerned growers to access when making a decision about which pesticide to use. A predictive model could give growers information to make decisions about which specific pesticide they should use to reduce potential consequences to the honeybees, to increase pollination, and most importantly to them, to increase their crop yield. Observations for 1994 in our data set only included data about the annual honey yield. So the data was used as the control for the amount of increase or decrease in the pounds of honey produced for the following year. Prior to developing the decision tree model, a new target variable was created called effect. Two binary variables, production decrease and neonic increase, were also created to be used to determine the value for effect. Production decrease compared a year's total honey production to the previous year's total for each state. If there was a reduction in the yield, then the observation was assigned a value of 1. Neonic increase compared a year's neonic usage to the previous year's total for each state. Since there was no information for 1994, a quantity of 0 kilograms was used for the control for the 1995 comparison. If there was an increase in pesticide usage, then the observation was assigned a value of 1. If both production decrease and neonic increase had a value of 1 for an observation, then effect was also assigned a value of 1. This was based on the assumption that honey production is negatively affected by an increase in pesticide usage. We hope to develop a helpful tool to determine which pesticides were least harmful in each state, but a decision tree model did not return the results needed. It only returned 2 of the 5 pesticides as important variables, TH and IM.
After you built the decision tree, we decided to kind of look into building a predictive model, and this can be used for the National Farmers Union. It will be a comparison model based on the pesticides you used. So maybe our end-term goal would be that farmers would look at this model and determine maybe I shouldn't use as much pesticide in this region because it's having a wider effect. So we chose to use regression to build this predictive model. And as we were building the model, we chose to break our data set down by region because different regions have different climates, they have different crops. So we want to look at it region by region base. The first region we're going to look at is the South region. In the South, you see that all the pesticides are significant on the total yield and the colony count as well. But you see that CL, IM, TH, AC pretty much all have a negative impact on the total yield. But you see that TI and TH, they have a positive impact. This can be as something that's seen as a positive thing, meaning that the colony count grew, or it can also be seen as a deterrent to the growth of the honeybee, because there's no telling how they would grow without coming in contact with these pesticides. But you see all the significant impacts on the total yield also have a significant impact on the colony count as well. The next region that we have was the West region. And we see that in the West, the IM and CL, they have a negative impact on the total yield. And TH, again, we see showing up as being significant and also has a positive impact. So it may be that the TH pesticide might be a good thing, might be a helpful pesticide in the growth of the honeybee. But you see that IM and CL are actually having a negative impact on the total yield. And again, that you see anything that has an impact on the total yield will also affect the colony count as well. So it would be nice for farmers to look at maybe the TH pesticide might be the only thing that's is beneficial for the honeybees.
As we continue to look at the specific regions, we see that in the Midwest, TI and CL have significant impacts, with TI having a negative impact on honey production, while CL has a significant positive impact on honey production and colony count. And finally, we see that in the Northeast, none of the pesticides are having a negative impact on the honey yield or the colony count. In fact, we see that 2 pesticides, TH and TI, were having a significant positive impact. A positive impact might be something that should prompt further research in that region.
So looking at our results, we see that in the South, all the pesticides, they played some type of significant role in the yield and the colony count as well. But we see that TH, it played a factor in pretty much everything. And TH was the only one that pretty much showed a positive impact on all regions. So maybe TH might be the only beneficial one of all the pesticides. So the other 4, they might need more further research to determine maybe we need to throw this one out, maybe we need to tweak something, maybe we need to tweak the usage. Something needs to be done because it's affecting these honeybees. And also with our further research, we want to see the climate, what kind of crops they're using, what kind of soil they have, because these factors will play some type of role in affecting the colony count and affecting the honey yield as well, because how these pesticides are being used, what kind of bees they have in this region, will have some effect on the reaction to these pesticides. And we're doing this because honeybees may not seem like a significant factor in this country, but as the research shows, they have a huge impact on everything that goes on in this country. So we want to be able to research this, give the results, and use these results to help farmers, to help everybody to determine we need to be doing something better to increase the honeybee yield and save our honeybees.
These are the 4 articles and websites that we gleaned information and data from for this study. The appendix includes further information about the different pesticides that we studied in this project. Thank you for watching our presentation.
And feel free to email us if you have any questions.